Allocation in the Omni world requires a complete picture of the demand, which means that you have to consider the potential demand for people walking into the store, as well as the demand that comes from people who are ordering online, but who happen to live in the vicinity of a store. The store demand can be estimated from the history of the sales of the store. And to estimate the demand for online orders from the vicinity of a store, you have to aggregate the web demand from a set of zip codes and enter it as an algorithm which optimizes which zip code should be mapped to a particular store. Then the allocator will have to make a strategic decision, which is what fraction of the web demand will be met from the stores. In general, the web DC is more efficient. The shipping and handling costs are lower to meet web orders. But during peak demand, the web DC can hit a bottleneck. In this situation, stores can meet the excess demand, but you have to plan ahead for this. So you have to make sure there's adequate inventory, which is where Omni allocation comes into play. And you also have to make sure that there's adequate labor hours to fulfill those packaging needs. The Android Omni allocation enables optimal inventory placement for this combined store plus Omni demand. So now let's walk through what the application looks like for managing the Omni demand. So for every style color, I have a web actuals, which is the line in the blue. And then I can test out different models, which does the forecast, as well as I have a backtesting period, which allows me to choose between different models. And this is all happening with our AI forecasting engine. So we have a forecast for web, we have a forecast for stores, and then we layer on both of these to come up with a Omni forecast. So I have a decision to make to say, hey, I want to meet 25% of my ship from store demand, the web demand as ship from store. So I can generate that, and that gives me an Omni sales curve, which is the store demand plus 25% of the web demand. Once I have this demand, I can now come and start allocating to that demand. And the basic idea behind an allocation is a balancing of demand and how much inventory we are allocating. So let's take a simple illustration. Let's say there's two stores, 40013 and 40014. This is product which runs extra small to extra large. And we have the demand for each store size, and we have this in the demand column. And in this case, we have a complex pack where each pack has extra small to extra large, it in a 12211 configuration. So we can allocate 4 units of the first pack to store 14. And then for each size, we end up in a situation of whether we are under allocated or over allocated. So if my demand for extra small is 4.9, but I allocate 4 units through the 4 packs, then I have under allocated by 0.9. And so I incur a penalty of a lost sale. And if I assume the initial price was $45, I have lost potentially, $39.60 in sales. On the flip side, the demand for extra large is 2.5 units, but I have allocated 4 units. So I have over allocated 1.5 units. So in this case, my penalty is not a lost sale, but excess markdown. And in this case, my markdown is 45%. And so on an initial price of $45, I'm going to incur a markdown penalty of $27. I can now sum up the cost of over and under allocation for this whole store. It comes to $100.35. And similarly, for my next store, I have a loss of $124. I add these two up and they come up to about $224. The goal of the optimization is to minimize this loss across all the stores. And all of that is happening behind the scenes through our application. This complexity is hidden from the user, but there's a sophisticated engine that's calculating this. For the user, they will come in, they will enter the application, they will make certain selections based on the channel, the merchandise hierarchy, and certain attributes. And these attributes could be delivery types like core versus replenishment products or season. And then they can come and choose one or more products. They will be able to keep a running tally. They can see like, okay, I've selected 2 items. There's total of over 6,069 units available, and I'm choosing to allocate 5,500 of them. So I'm reserving 569 units. Once I've selected my products, I can go and apply constraints. The key constraints are what's my presentation minimum for my initial allocation and what's my presentation minimum for my replenishment, right? So in this case, I'm running a replenishment. So I can say I want to maintain at least 3 units. And this updates my presentation minimum. So this becomes a business policy that the optimization will have to follow. Once I've done that, I can click optimize, and then I will get a view. So for every style color, I can get the store level allocation, how much got allocated to each store, how much was on hand already, and what's the final position. Or I can take the store level view, and then I can see for every store how much of each style got allocated. Once I am happy with my allocation, I can just click and say, export this to the warehouse management system, and then this can be executed upon. Thank you for listening, and please reach us with any questions.